Hello and welcome to another video tutorial on normalization. Today is a continuation, a part two of demystifying normalization. Based on some feedbacks received on the first one, which is functional dependency, I'm doing this video to um, further enhance our understanding on functional dependency. And so normalization. Um, is very related or is closely related to set theorem. And one may ask, what is the link? So basically, when you organize data into a well-structured tables or into structured tables, you are basically doing what is referred to as decomposing a set or regrouping related items, in a set. And we'll be looking at that in the next slide. So let's take this table, for example, to understand what we mean by the fact that set and theorem and normalization in database are closely related. So when we pick a table, just like this here, the student table, we will notice that we have the bigger table, which is a database being represented in a set relation form. Okay, we are represented in a set form. So here we have the student um, ID S01, whose AMA and setting maths in the one row on the first row in one set. And then when we move to the second row, we have the same student, however, reading English. And then we come to a second student, that's Kwame, reading another subject, right? So when you have a table decomposed into a set, basically that is all there is to normalization. So our observation here is that each row is an element of the set, and then the table is a collection of related data items. So basically that is what normalization is. So let's paint the picture this way. um, Normalization is basically asking one question. So what is it really asking you to do? So basically it is asking you to group items, and by saying that, say what goes with what. And in grouping the items, you have to ask yourself which data set or which field determines another set. So what data set goes with what set? Basically, that is all there is. And everything else, which is 1NF, 2NF, 3NF, is basically a precise way of saying the same thing. Okay. You have not finished answering it yet. I mean, it's basically saying the same thing. What goes with what? And that is just a fine way of um, doing the same thing. All right. So now let's look at the big picture here. In this set here, we have oranges, banana, watermelon, tiger, lion, frog, books, pens, textbooks thrown into a big mixed bag, right? And you notice that this here has no relationship. I mean, there's no structure. It's just data and information that is lost in this mess, right? Now, that is basically what it means to have a flat file, right? So that is it, a flat file. Now, but if we look at this carefully, we notice that banana, orange, watermelon has something in common in the same sense. Tiger, lion, frog also have something in common, as well as books, pens, and textbooks. So we can categorize these items. So the question now is, if I know one thing, does it always tell me something else? And the answer is yes. So if I say fruits, that is a bigger category. Do I know what goes inside that item? And if I say animal, do I always get the same items? If I say stationary, do I always get the same items? If the answer is yes, then that is basically what we mean by functional dependency. All right. So in categorizing the various items we had in a bigger set, we now have three subsets. The first set being fruit, the second set being animal, and the third set being stationary. Okay, so we have three subsets, which are when you put together, you get the bigger table, which is the unnormalized table, right? So the category is always what will give you the items that goes into it. So knowing the categories will always tell you what items belongs in there. And so the category is the determinant in this case, and it determines what goes with it. All right. Now, so in proving the arrow, or we want to test in both direction whether one item is able to determine the other. So here, for example, if I have category, will I be able to determine the item that goes into it? And he said yes, so it means it works. So if I have fruit, banana, orange, obviously falls under the name fruit. But if I pick just an item, say banana, I don't know what else falls under banana. I mean, it's not a bigger group, or it's not a category under which other items can fall. So knowing banana does not always tell you that these other items fall into the same category. So there's no function dependency in that direction. However, if I know fruits, which is a bigger name, I can now identify other items that falls under it. So in a nutshell, from the set theory to database tables, what we are saying is that the set language is very much related to the database language. So an organized set is the same as a flat file or a normalized form. And then sorting items into subsets is basically what you do by decomposing the tables. And that is taking them to 1NF and 2NF and 3NF, right? And the properties that define each subset are the primary keys. Inside, or the items inside a subset are basically the attributes of that table. And then A determine B is a functional dependency that exists between the table. Items appearing more than two times in a subset are basically foreign keys that link one table to another. And then when you have the same item repeating itself unnecessarily, then we refer to that as a redundant data. So we can see clearly that the set theorem has some big relationship with database. And once you have this understanding, and you have a table or a question before you, the first thing you need to do is to find out whether you'll be able to categorize those questions into different categories, the items into different categories. If you are able to do that, then you are one step ahead in solving the problem. So in a case where there's not going to be categorization, then we're going to depend solely on functional dependency, which you can find in the video, and I'll put the link up above. So you click on it if you have not watched that video. Go back to watch it to understand functional dependency. So basically, these two approach, right, are the basic ways of solving problems as far as normalization is concerned. I had a few issues or concerns um, as far as the first video was concerned. I noticed a lot of people had um, in some of the videos when it comes to repeated groups or identifying tables that are in the first NF, right? So if we look at this table in this example, I've labeled them as UNF exam definition. So in this case here, we notice that we have non-atomic data and multiple values in one cell. So the non-atomic data is the student's name, basically made up of the student first name and their last name. And the repeated values or repeated groups are the subjects. So you notice that we have different subjects that are separated with commas. So this here is a repeated group, and the heading or the field being shaded in red, right? So when you see tables in this form, they are basically in 0NF, or they are not normalized. They are UNF, a normalized form, right? In the same sense, you notice that even though there's a primary key here, these two things here makes this table not to be normalized. Now, again, when we come to this table here, we notice that we have repeated groups, columns that repeat for each instance. So the student one, right? So it's basically this table that I have brought down again here. And this time around, we have just the student ID and the subject the student is studying. And then you notice that we have subject one, two, three. Again, we have a repeated group or a repeated column. Whenever you have a repeated group or a repeated column, even though there's an ID or a primary key, this does not qualify to be in 1NF or first NF. So basically, the characteristics of a table in 0NF or not normalized are: one, it has repeated groups, and then two, um, they are non-atomic values, and then finally there are no primary keys. So, and some mm, common mistakes a lot of people make is that when you leave repeated groups and you think the table is in 1NF, then that is not right. Okay. So in a nutshell, that has to do with the explanation moving from 0NF to 1NF. So you have this question to try, um, test yourself, and let's see if you're able to get it right. So here I have a bigger set that is booking, and in that booking we have different attributes. And here I've given you a guide on how to go about it. I've given you the functional dependency that exists in here. So I have flight ID, that is the primary key, giving you the airline name and the flight date. In the same case, I have the customer ID, giving you the customer name, and then the customer ID plus the flight ID should give you the student's seat number. I need you to pause this video and see if you're able to normalize this to the third NF. All right. Um, in our next videos, we'll be looking at other areas where we will solve some past papers on normalization using functional dependency, as I've mm, given you hint about. We use a categorization approach, which is a set notation trying to categorize items within a table, or we use solely the functional dependency approach in getting what we want. Right, so till we meet again in the next video, hit the subscription button, click the like button, and share the video for others to benefit. So till we meet again, bye bye.